Okay, this one is reverse. So just like it sounds, it's pretty straightforward. We're gonna take in a tuple and then we're gonna flip it upside down, reverse it. So we have a couple tests here. Of course, for an empty tuple, there's only one way to solve that. So it's pretty straightforward. But for every other case, the first element becomes the last element and so forth. It does. This is one of those tests that does ask us to make so I guess we can start out just like that. It asks us to make a generic constraint. So I guess we want a string array or something. I guess it would be like an unknown would be fine. Doesn't only have to be strings that we're flipping. All right. So I'll set you up with the same exact thing. We have like the sort of infer head, infer tail. And then, yeah, here's the same thing. So like from a pseudocode or just like broadly speaking, where would you start on something like this?
In the case where, so to go back to the last one, just so I follow the cases.
So yeah, like this one. So, okay, so the first part is saying like, if you have items to grab.
Yes. Okay. So that's what this, so I was wondering like when this passed and when this failed. Because like t extends, it's not clear to me initially, like immediately, like this is false when there's nothing left in the list. What we can do that makes it pretty obvious.
Yeah. Like the nice way to debug this, and sometimes I'll do something like false is okay, but like I'll put in like 2 or some number in here. And then if we go up to the other things that are here, I wish there was a case. Okay, we're gonna like screw this one up for a second. But if we go up here, we can see that A2, like reverse of A2 is just A. And if we pass in tail instead of head, we can kind of like inspect what the values, there's no like debugger for this stuff, which is kind of annoying. We see that it's an empty tuple for A2. But if we go to A3, it's going to say BC.
That makes sense.
So head is always like the very first thing, and it works this way with strings too. And then, so the recursion happens here,
It's pretty simple. Like at this point, you just call it, or in this case, call tail on reverse and append to the end, and then the other case like, just return it.
Reverse, tail, and then, I don't know, head. And this probably has to be like, I think like that, maybe? What did we do? Oh, because we broke it. Okay, A, B. Everyone's happy. Yeah, perfect.
Nice.
This one is pretty straightforward because it's basically, it's like really simple from a functionality perspective. I found one little alternative, which is that you can actually, the syntax allows you to spread at the beginning. So, functionally equivalent, but if you spread at the beginning, then the tail is just the last element, and you can put
that's much less intuitive to me. And I feel like, I don't even know if other languages with pattern matching would honor that. That's just a strange pattern to me.
Well, I think we're going to do one in a little bit that has like 3 things. You can put like, there's one solution that allows you to like take the middle element of something like your, is palindrome. That's it. There's a challenge that allows you to return true or false whether or not the input string is a palindrome. And the way you solve that is by saying like left, middle 1, middle 2, right. It's like pseudocode, but you can put all kinds of things in here, and it will infer, it'll pattern match kind of on all of those things pretty well.
I just didn't know that you could spread early is the thing that's news to me.
Yeah. I'm not sure I know of a reason to do it. Usually it's just like, I don't know. It's made more sense to this person, but oh well. Okay, well, that's an easy one.